we have finished addition of vectors using triangle law, parallelogram law, polygon law in part 2. In part 3 of mathematical methods, we are going to see multiplication of vectors. A multiplication of vector can give you a scalar answer. So we can have the scalar product or the dot product. Let us take the example of work is equal to force into displacement. Though force and displacement are vectors, work is a scalar quantity. So we are talking about such multiplication. Let us take a vector A and a vector B and let the angle be theta between them. We drop perpendicular up to A from B. This will give you B cos theta. Similarly, we can drop a perpendicular from A to B, and that will give you A cos theta. We can write A vector dot B vector is equal to A into B cos theta, that is equal to B into A cos theta. Thus, the scalar product of two vectors is defined as the product of the magnitude of the two vectors and the cosine of the angle between them. So, if A vector and B vector are the two vectors with angle theta between them, then A vector dot B vector is equal to magnitude of A into magnitude of B into cos of theta. The product is a scalar quantity. It does not have direction. Let us see the characteristics of the scalar product or the dot product. The first one is just the definition. If A vector and B vector are the two vectors with angle theta between them, then A vector dot B vector is magnitude of A into magnitude of B into cos of theta. The second one is that a scalar product is commutative. That is, A vector dot B vector is equal to B vector dot A vector. The third characteristic is it obeys the distributive property. Therefore, A vector dot into B plus C, that is B vector plus C vector, is equal to A vector dot B vector plus A vector dot C vector. The fourth one talks about the unit vectors. Now, you know, if you take two unit vectors I and I, the angle is 0 over there. So, let us take I cap, j cap, k cap as the unit vectors along the x, y and the z axis. Then I cap dot I cap is 1 into cos of 0. But cos of 0 is 1. Therefore, 1 into 1 into 1 is 1. Similarly, we can write j cap dot j cap is equal to k cap dot k cap, which is equal to 1. If we have any other two parallel vectors, say A and B, then A vector dot B vector is equal to magnitude of A into magnitude of B into cos of 0. When the angle is 0 between A and B, they are parallel. And that gives you A into B, just the multiplication. So, if A vector is equal to B vector, then A vector dot A vector will be A square. If two vectors are antiparallel to each other, then theta is 180 degrees. So, A vector dot B vector is magnitude of A into magnitude of B into cos of 180 degrees. So, A vector dot B vector is minus AB. Now, let's see the next characteristics where I cap dot j cap. That means you have I in the x direction, j in the y direction. The angle is 90 between them. Similarly, between j and k, the angle is 90. And k and I is 90. So, you have I cap dot j cap is j cap dot k cap is equal to k cap dot I cap is 1 into cos of 90. Cos of 90 is 0. Therefore, it turns out to be 0. If you take any other vectors perpendicular like A vector dot B vector, that is equal to AB cos of 90, that turns out to be 0 too. So, we come to a very important conclusion over here. If two vectors are perpendicular, then their dot product or cross or the scalar product is equal to 0. So, if you take the position vector of A vector is equal to AX I cap plus AY j cap plus AZ k cap. Similarly, the position vector of B as Bx I cap plus By j cap plus Bz k cap. You take the dot product of the two, you do the algebra over here and you get terms in I and I, j and j, k and k, and also ij, jk and ki. Now, what we observe is that after multiplying, you have I dot j, the I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is 0. We have seen already. And similarly, the commutative one, j cap dot I cap is equal to k cap dot j cap plus I cap dot k cap, which is 0. So, all those terms we substitute 0, and what remains behind is just A vector dot B vector is AX BX I cap dot I cap plus AY BY j cap dot j cap plus AZ BZ k cap dot k cap. But we also know that I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is 1. So what we get is a vector dot b vector is equal to x bx plus ay by plus az bz. So we find that the left hand side is a vector whereas the right hand side is a scalar. So that gives you the scalar product. Now let us see a vector product. You have the same force and displacement. If you multiply, you also get torque. Torque is a scalar, not a scalar, it's a vector. Whereas in the previous one, work was a scalar. So let us see such kind of vector product. So you have a vector over here, you have a b vector, and then you have the angle theta between them. You have the cross product is perpendicular to the plane of a and b. So you have a vector cross b vector. As a vector product of two vectors is defined as the product of the magnitudes of the two vectors and the sine of the angle between them. So if a vector and b vector are two vectors with angle theta between them, then a vector cross b vector is equal to magnitude of a into magnitude of b into sine of theta. The product is a vector quantity. Since it has a direction, the direction is given by the right hand screw rule. Now let's see the characteristics of the vector product or the cross product. In the same lines as the scalar product, if a vector and b vector are the two vectors with angle theta between them, then a vector cross b vector is ab sine theta. The second one is the vector product is not commutative here. So a vector cross b vector is not equal to v vector cross a vector. This is not same as scalar product. Then the third one is similar to the the scalar product. So vector product is distributive. A vector cross b vector plus c vector is a vector cross b vector plus a vector cross c vector. The fourth one in similar lines, I cap, j cap, k cap are the unit vectors along x, y and the z direction. Then I cap cross I cap is 1 into sine of 0. But you know sine of 0 is 0. So I cross I will give you 0. Similarly, j cap cross j cap plus k cap cross k cap is equal to 0. If the two vectors are parallel to each other, then a vector cross b vector is equal to ab sine 0, that is equal to 0. If the vectors are anti-parallel, then again theta is 180 degrees, but see sine of 180 is again 0. So we also have the anti-parallel ones as 0. So if two vectors are parallel, then their cross product is equal to 0. A very important conclusion. Now the last characteristic is if the magnitude of I cap cross j cap is equal to j cap cross k cap is equal to k cap cross I cap is equal to 1 into sine of 90, which gives you 1. The direction is perpendicular to the plane by right hand screw rule. So I cap cross j cap will give you k cap. J cap cross k cap will give you I cap. And k cap cross I cap will give you j cap. So if two vectors are perpendicular now, any other two vectors, so then a vector cross b vector is ab sine 90, which is ab. The direction is perpendicular to the plane of ab. Now let's see the cross product. So you take the position vector of A, position vector of B, do the cross product, open up the brackets, same as in scalar product, but now you have cross. So you know the same ones, I, J, K, K, that is I cross I cap cross I cap is equal to J cap cross J cap is equal to K cap cross K cap, which is equal to 0. So these terms become 0 and the remaining remains behind. But we also know I cap cross j cap is equal to k cap, j cap cross k cap is equal to I, k cap cross I cap is equal to j cap. J cap cross I cap is equal to minus k cap and k cap cross j cap is minus I cap cross k cap is equal to minus j. This is in the cyclic order I, j, k. Okay. So we get the terms a vector cross b vector is ay bz minus az by I cap minus ax bz minus az bx j cap plus ax by minus ay bx k cap. We can write it in the determinant form as a vector cross b vector in determinant I, j, k, x, ay, az, bx, by, bz. So we can find the determinants and get the cross product. So that's all for now. Thank you.